Hello students and welcome back. Today we're going to be starting a new unit, and in this unit we're looking at inverse functions. Two of these functions are the square root and the cube root, and we're going to first of all look at their graphs. So a square root function has a square root of a variable. So your basic one would be y equals the square root of x, and I went ahead and graphed this one for you. You'll see that on the left side, so the left end behavior, it has an initial point, a beginning point, so it does not go on and on forever. On the square root of x, it would be 0, 0. And then on the right end behavior, the graph continues to go on. It would have an arrow actually showing that it goes on. So we have an example for us to look at of a square root function. You will have functions like this to do a matching homework with, much similar to what we did with the polynomials. So your first problem is f of x equals 2 times the square root of x plus 1 minus 3. Probably the first thing you'll want to do is go to Desmos. So I'll go there so you can see how to type this in. Now you'll need to bring up the keyboard, and remember you can use y equals or you can use f of x equals. The keyboard will have your square root. Now remember there was a 2 in front of that square root. So 2 times the square root, and then inside the square root was the x plus the 1, and then make sure that you get outside of the square root, and then minus 3. So we'll verify that that was the problem, 2 times the square root of x plus 1 minus 3. Then bring the keyboard down so that you can see you have this graph with a y-intercept of 0, -1, and an x-intercept of 1.250. Now the initial point does not show up on Desmos other than for you to actually select that point and hold on it. So you'll have to take note of the fact that this initial point is -1, -3, and then look for, on your homework, you'll have to look for the graph that matches having that initial point in that location. So once you've got it graphed on Desmos, then you'll come back and answer some questions, again, with the matching answers being provided for you. So on the left, you'll see that we have this initial point. Initial means beginning. So we have the initial point, and in this problem it is -1, -3. Now I would like for you to notice as you go through the assignment that the x of that initial point will always be the opposite sign of the number inside the square root. And the y of that initial point will always be the same sign number as what's outside of the square root. So again, the initial point will always be the number with the opposite sign from inside the square root. That will be the x. And then the y will be the exact number, including the sign, from outside of the square root. So there's the left end behavior. The right end behavior of this graph is that it continues on going up. And so we'll say that the right end behavior is up. And then we'll notice that on each question, you're going to have a question about whether it is a point of inflection. Now, points of inflection are for cube root graphs. This is a square root, and so there would be none. So square root graphs will not have a point of inflection. They will only have initial points. All right, then we will look at the graph to tell us the y-intercept. So the y-intercept is the point where the graph crosses the y-axis. This would be the ordered pair 0, -1. We will look to see the x-intercept. The x-intercept is where the graph crosses the x-axis. Now, that is not always a whole number, and in fact, on this one, it is not. We have the decimal 1.250. So come back here to write this 1.250 as our x-intercept. And then just as we found with polynomials, the solution is the x from the x-intercept. So the solution would be 1.25, the x from the x-intercept. So there aren't as many special points that occur on the square root graphs. I will emphasize that all square root functions have initial points, but it is possible that square root functions do not have y-intercepts or x-intercepts or solutions. So it is possible that you would be writing none on the y-intercept, the x-intercept, and the solution. If that graph is started so that it never crosses the x-axis or never crosses the y-axis. Let's say, for example, you had a graph that went like that. That would have no x-intercept, no y-intercept, no solution. But it does indeed have an initial point. So that's what a basic square root graph looks like. And then if you'll turn your papers over, we will look at a cube root graph. So continuing on this side of your paper, we'll be looking at the cube root graph. And the basic cube root graph is y equals the third root of x. So notice that a cube root of a variable is what makes this a cube root graph. And notice that the little root symbol has a 3 in it. You say that as a cube root or a third root. These types of graphs have, instead of initial points, they have points of inflection. You'll notice that on this graph, the point of inflection is at 0, 0. This is where the graph changes curvature. And then the behavior on the left, one side will go down, the other up. So on this one, the left side is down, the right side is up. So we will look at your first example or your one example of your cube root function, and that example is shown at the bottom or middle of your page. So you have f of x equals 2 times the cube root of x minus 1 plus 3. So the first thing you should do is go to Desmos to type this in. And so we have y equals, remember there was a 2, and then you're going to need to bring up the keyboard. The cube root is found over to the right where it says functions. Then usually it starts off on trig. You're going to have to go over to miscellaneous, and then down at the middle row, third row from the middle column, third row from the bottom, is the little root symbol. It'll let you put in a 3 in the hook to tell it that you're doing a third root. And then your function is x minus 1. And then outside you have plus 3. I'm going to verify that that is the correct function. So the third root of x minus 1 plus 3. You'll notice that the x-intercept shows up, the y-intercept shows up. The point of inflection does not show, so you'll have to search for it while you're looking for it on Desmos. But as you're looking for it on your homework, it will be designated for you. I will point out that the point of inflection has for the x, it is the number inside the square root with the opposite sign. So in this case, that would be a 1. And it is for the y, the number outside the square root using the sign that's there. So a positive 3. So the point of inflection on this problem is 1, 3. So we'll go back to your notes and begin answering the questions about that graph. So we'll start with the left behavior. The left-in behavior for this graph is that the graph is moving down. So we'll fill in that blank down. On the right-hand side, you can see that the graph is moving up. So for the right-in behavior, the graph is up. And then this point of inflection, which is showing to you here on the screen, and again is the ordered pair 1, 3. If you'll notice, opposite sign, but inside the square root, that's your x, and then same sign outside the square root is your y, 1, 3. These types of graphs have points of inflection instead of initial points. Then your y-intercept taken from the graph is 0, 1, and that's where the graph crosses the y-axis, so 0, 1. And then your x-intercept is the point where the graph crosses the x-axis, and so that is a decimal again, negative 2.375, 0. You'll always have a 0 for the y value on those x-intercepts. And then the solution is the x from that x-intercept, so negative 2.375. That would be the solution of that equation set equal to 0. So just a couple of comments about cube root functions. All cube root functions will have a point of inflection, and this is where you'll see the graph making a turn or changing its curvature. And then all cube root functions, so this is different from the square root. All of them will have a y-intercept, an x-intercept, and therefore a solution. So you'll be filling in using the matching capabilities that we've given you on a separate sheet of paper to do your homework 5. So if you have any questions, be sure to ask your teacher, and good luck with this assignment.